Hello, and welcome to today's lesson on the voltage of a cell. In today's lesson, we will understand that the voltage produced by a cell is directly related to the reactivity of the metals used in its electrodes. So far, you've become familiar with how chemical cells work. You know that a chemical cell converts chemical energy into electrical energy by using two electrodes and an electrolyte. Building on this foundation, we will enhance our chemical understanding by exploring why the voltage produced by a chemical cell varies depending on the metals used as electrodes. Let's get into it. Metals vary in their reactivity, which is their tendency to lose electrons and form positive ions. Some metals, like zinc, are highly reactive, while others, like copper, are less reactive. The reactivity series is a list of metals arranged in order of their reactivity, with the most reactive metals at the top and the least reactive at the bottom. Highly reactive metals, like potassium, tend to lose electrons easily. Less reactive metals, like silver, do not lose electrons as easily. When you place a more reactive metal, like zinc, and a less reactive metal, like copper, in a cell, the more reactive metal will act as the anode and lose electrons. Meanwhile, the less reactive metal will act as the cathode and gain electrons. This movement of electrons from the anode to the cathode through an external circuit creates an electrical current. When two metals with a large difference in reactivity are used, the flow of electrons is greater, resulting in a higher voltage. The greater the difference in reactivity between the two metals, the higher the voltage produced. For example, a cell with zinc, high reactivity, and copper, low reactivity, will produce a higher voltage compared to a cell with iron, intermediate reactivity, and copper, low reactivity, because the difference in reactivity between zinc and copper is greater than that between iron and copper. Different metal combinations in batteries affect their performance and voltage output. Understanding the reactivity series helps in designing efficient batteries for various applications, from small devices like smartphones to larger systems like electric cars. Let's try some examples. Question 1. Predict which cell would produce a higher voltage: a cell with potassium and copper electrodes or a cell with magnesium and copper electrodes. Explain your reasoning. From the reactivity series, we can see that potassium is more reactive than magnesium, and copper is less reactive than both potassium and magnesium. Since the difference in reactivity between potassium and copper is greater than the difference between magnesium and copper, the potassium-copper cell will produce a higher voltage. Question 2. Predict which cell would produce a higher voltage: a cell with magnesium and silver electrodes or a cell with zinc and copper electrodes. Explain your reasoning. From the reactivity series, we can see that magnesium is more reactive than zinc and that silver is less reactive than copper. We can thus order those four metals in terms of reactivity as magnesium, zinc, copper, silver. This clearly shows that the difference in reactivity between magnesium and silver is greater than the difference between zinc and copper. Hence, the magnesium-silver cell will produce a higher voltage. In today's lesson, we delved into the relationship between the voltage produced by a chemical cell and the reactivity of the metals used in its electrodes. We explored the concept of metal reactivity, understanding that metals vary in their tendency to lose electrons and form positive ions. We then discussed how placing a more reactive metal as the anode and a less reactive metal as the cathode creates an electrical current due to electron flow from the anode to the cathode. The greater the difference in reactivity between the two metals, the higher the voltage produced. By understanding these principles, we can predict which metal combinations will produce higher voltages, aiding in both theoretical studies and practical applications like battery design.